All right, so we are back to R3, and we are going to let's write down what we're going to talk about today, and then we'll talk about it. We're going to do congruent, which I mentioned a few minutes ago before I started recording. Congruent, but I didn't mention this, okay, things that are called similar. And I think we're just doing triangles. Yes, we are, okay? Similar triangles. All right, congruent and similar triangles. They are not the same thing. They have some things that are in common, but they are not exactly the same thing. So let's start off talking about congruent. What in the world does it mean to be congruent? Say it again. Well, not similar. All the sides are equal, and all the, what else? Angles are equal to each other, okay? So, but I'm going to say it like this. We're going to say that the corresponding, and we'll talk about that here in a second, because that's pretty important. I can't just say all the sides are equal. Somebody open the door, please. I can't just say all the sides are equal, but I can say that the corresponding angles, that's the symbol for angle, and apostrophe S, that's what that mess is supposed to be. Thank you. And the corresponding angles and the corresponding sides are congruent. Do you remember the symbol for congruent? It's an equal sign with a little squiggly thing on top of it. Okay, so we save congruency for shapes, all right? Numbers, if I talk about the length of something or the measure of an angle, I would say equal a lot of times. But when we talk about shapes that are the same, then I would say congruent. All right, let's do a picture. Let's push this up a little bit. We'll get to similar in a few minutes. All right, let me try to draw this. And let's see. This comes down about like this. All right. And then I'll make this go like this. So draw the triangle that looks kind of like that. And what I'm going to do is I'm going to copy and paste it. So if I copy and paste it, guess what's true about both of these triangles? They're exactly the same, right? And I'm even going to twist it a little bit. Just because I twisted it, does it mean it's going to be any different? No. If I can grab it, daggone it. It's very picky. There it goes. Okay. All right. So let's put some, I don't know if these numbers will even work or not, but I'm going to say this is 5, this is 7, and this is, I don't know, 14. Okay? They're probably not accurate. That's perfectly fine. But if I say that this angle, or this side, sorry, and this side, and this side, is that enough to say that they're congruent? Because look at the definition of congruent. The corresponding, what? Angles, which I don't know anything about just yet, do I? And the sides are congruent. When I say corresponding, they're the ones that match up. So if I could take one, pick it up, twist it, and stick it right on top of the other one, okay, if I can do that and they match up exactly the same, then they're congruent. Make sense? Yeah. Okay. If I if all the sides are equal, it does make them congruent because it's something we're going to talk about a little bit later. All right. But anyway, all the sides are equal to each other, all the corresponding sides. So this side right here, that's kind of like your shorter side. That's 5. The middle side is 7. That's 7. The longest side is 14. That's 14. So yes, they are congruent. But you'd also have to show something else, that the angle opposite that side has got to be the exact same as the angle opposite the 5 on the other triangle. Does it seem extra hot in here today? Is there a thermostat? Is there? What's it at? Can you punch it down a couple? See if Mr. Rouse. Could we take it down a couple degrees? Would that be possible? Thank you. All right, let's take a look. Do you see how I put this little arc right here? Okay, that means that this angle is equal to this angle. In fact, should I put some numbers? In my example, I put numbers here, but let's just put these arcs. Okay, that's good enough. All right, so if this has got one arc and this has got one arc, what does that mean about those two angles? They're exactly the same, right? Okay, if I put 2 here, where would I have to put the other one for it to correspond? Which one corresponds to this angle? Okay, this one up here. Now I twisted it, so it's a little bit more confusing, but how do I know that this one corresponds to this one? Because if you look at and see the side that it's opposite, everybody's watching? Okay, Carter? You're not watching. So this angle right here is opposite to 14. So you look over here, what angle is opposite to 14 over here? This angle up here. Do you see it? I should label these, shouldn't I? We'll call this A, B, C. What would be A over here? Right, because A is opposite to 5. So if you come over here, actually, I shouldn't even use A. Here's something that's kind of weird. You've probably never seen before. Everybody, watch this. I could use different letters, and I should use different letters, but watch. I'm going to put a little dash thing right there. They call it A prime, all right? So instead of just using letters, I could say that this is A prime, all right? You've probably never seen that before, but they do that a lot in math sometimes, okay? All right, so that's what I'm going to do. Instead of calling it X, Y, Z, I'm going to call it A and A prime. It's basically like a different letter, right? But I just put that little prime thing next to it. So it is different, but it's the same because they're equal. All right, so if angle B is opposite 14, come over here, this is going to be B what? B prime. And if this C right here is opposite to 7, what's opposite this 7 over here? This one right here, and I'll call it C what? C prime. Everybody with me on that? That way you know which ones go with what, okay? The A and the A prime to go together, the B and the B prime, C and C prime. All right. So if angle B has 2 arcs over here, then B prime's got to have 2 arcs. If angle C has 3 arcs, then C prime's got to have 3 arcs. Everybody with me on that? All right, so that means that all the angles, all the corresponding angles, all the ones that match up together, if I took this, picked it up, and was able to stick it right on top of this and everything matched up, then the A and the A prime would be in the same spot, B and B prime would be in the same spot, C and C prime would be in the same spot. Yeah? Okay. If all the angles and all the sides are exactly the same, then they are what? Congruent to each other. All right? We have a few theorems. We're not going to get into as much detail as we would in a geometry class, but I just want to, this is just review. So, I got to draw all these triangles. That's okay. I'll draw them. Because all I got to do is just draw a few of them. Then I can just copy and paste. That's always real nice. Okay, draw a triangle that kind of looks like that. Doesn't have to be exactly the same. But I'm going to copy and I'm going to paste. And if I could grab it, there we go. Got it on the first shot. Now, right now, do you know, if you didn't know I copied and pasted it, would you know that they're congruent triangles? No. They look like it, right? I mean, they look really close to the same. Well, they are because I copied and pasted. But if I just drew it, you wouldn't know. You have to be told certain things. So if I told you that this side and this side were equal, this one and this one, this one and this one, and I also told you that this angle is equal to this one's equal to this one, and this third one's equal to this third one. If I told you all that stuff, then you could say that they're congruent triangles. But you don't have to be told all of those things. There's 6 things that make it congruent. You don't necessarily have to be told all 6 things. You could just be told this. We could kind of cut it in half. Where if I told you that this angle was equal to this angle, and this one down here was equal to this angle down here, that's not enough to say that they're congruent, okay? But if I did this, watch. If I said that this side was equal to this side right here, I haven't told you everything, but I've told you enough. Again, in geometry, we would explain it a lot more deeply than this, but this is just review, all right? What we have here is an angle, we have a side, and we have another angle in one triangle equaling the corresponding angle, side, and angle of the other triangle. Everybody see that? So if let's go ABC. Let's not do the primes on this one. Let's go XYZ. So if I told you that angle A was equal to angle X, and that angle B was equal to angle Y, and line segment AB was equal to line segment XY, that's enough to say that these triangles are congruent. I don't even have to know anything about side AC and XZ. I don't have to know anything about BC and YZ. I don't have to know anything about angle C and angle Z. This is all I have to know. If I know that amount of information, what can I say about these two triangles? They're congruent to each other, okay? And we have a reason for that, and they call it the angle-side-angle theorem. Again, I'm not going to go really deep into it because it's not geometry class, we're just reviewing, but it's called the angle-side-angle theorem. Do you see how you have an angle, a side in between those two angles? See how that side is in between these two? So if I have an angle, a side, and an angle, and the same thing over here, this angle, this side, this angle are equal to these, then these two triangles are exactly the same. I don't even have to know the measurement of AC and BC and XZ and YZ. I don't have to know it, okay? And there are proofs for it. We're not going to go through it today, or probably ever in this class. In geometry, we would. So we could say those two triangles are congruent. How do I write that? Like over here. What do you want to call this triangle over here on the left? Okay, let's call it triangle ABC. And it's congruent. Now, this is very important. Okay? If I went A, B, and C, I went from the one arc to the two arcs to the no arcs. Do you see it? That means I have to write this one over here in the same exact order. Okay? So I went 1, 2, none. How is this going to be written? X, Y, Z. It's not because it's in alphabetical order. It's got nothing to do with that. It has to do with which angles correspond with which angles. Okay? What angles here correspond to the angle over here? So if I took one, sat it right on top of each other, A and X would be the exact same angle, wouldn't they? Okay, B and Y would be the exact same angle. C and Z would be the exact same angle. All right, if I pick this up and put it right on top of this. We good with that? Yes. All right. That's how you write it. So that's pretty important. It's very important. There's another theorem. There's 3 theorems that we're going to do for congruency. All right, so let's do another one. Let's draw another picture. I'll draw it like this. I'll draw it like this. And I'll draw it like this. All right. And what I'm going to do is I'm going to copy and paste it. So you know, just from the fact that I copied and pasted it, they're exactly the same. But right now, I haven't given you any information on it at all, have I? But what if I do this? What if I tell you that this side and this side are equal? Does that mean that they're congruent just with that? No, these could be all kinds of different shapes and still have just those two sides equal to each other. Okay? What if I had this and this? That's not enough. Okay? But watch this. If I had that this side was equal to this side, if I had all 3 sides, I don't know anything about the angles, okay? But if I have all 3 sides on one triangle equaling all 3 sides of another triangle, that's enough to say that these triangles are congruent. And if we call this the angle-side-angle theorem, what do you think we're going to call this? Side, side, side. Very good. Pretty easy, right? Yeah. But you remember all this from geometry, don't you? Okay, a little bit. It's coming back to you. Side, side, side theorem. I don't have to know anything about the angles. All right? If all I know is 3 sides of one triangle equal 3 sides of another triangle, I know those triangles are congruent to each other. That's all I got to know. Now, knowing that they're congruent, what do you think I could say about this angle right here? We'll call it angle A again. We'll call this X. What could I tell you about angle A and angle X? They didn't tell us anything, but I do know they're congruent, right? That means I can pick one up, put it right on top of it. It means they're exactly the same. What do you think I could say now about angle A and angle X? Yeah, I could say that they're equal to each other, right? And we have a special word for it. I don't know, do you remember this from geometry? It's called corresponding parts of congruent triangles are equal or congruent. Depends on what book you use. Nobody remembers that? Okay, I got a couple people that remember this, okay? But that's the reason. If I ask you a reason, why is angle A equal to angle X, and I asked you why is it true, then you would say that the corresponding parts of congruent triangles are congruent, all right? I'm not going to delve into that much more. But anyway, I just was curious to see how many people learn that stuff. And maybe it was taught to you. Believe me, I've learned. Just because you don't know it doesn't mean it wasn't taught to you. So it might have been. All right, let's do one more of these kind. Let's make this look like this. Oops. Gotta click off of it. I gotta do this. Missed it, didn't I? Let's make it look like that. Let's push it over. I don't like it hanging around like that. There, looks a little bit better. Okay, and then let's go like this. Little skinny triangle. By the way, what kind of a triangle is it? This is bigger than 90 degrees. It's an obtuse triangle. Very good. All right, so again, I'm going to copy and paste this and put it right here. Now, you know that they're going to be congruent to each other, but you don't right now. Technically, you don't know because they didn't tell you anything. If they just put two triangles down and they look the same, you cannot assume that they're just congruent to each other. You have to use these theorems, okay, that we've been talking about in order to say if they're congruent or not. Does that make sense? Okay, so don't just look at it and make an assumption about it. On the SATs, I believe that they do have some questions about congruency. And you may be fooled into thinking that these two triangles are congruent, but they don't give you enough information. All right, so you cannot just assume that they are congruent to each other. But what if they told you this? Okay, they told you that this side was equal to this side. Is that enough to say they're congruent? No. Okay, but what if they told you that this side and this side are equal? Is that enough to say that they're congruent? No, not just two. If I knew all three, yeah, then they'd be congruent, right? But here's something they tell you. They tell you that this angle between those two sides, everybody see that? Okay, between those two sides, it's very important, is equal to this angle between those two equal sides. Now that is enough, okay, to say that those two triangles are congruent to each other. So we did angle, side, angle first, and we did side, side, side. What do you think this one's called? Side, angle, side. Very good. It's pretty straightforward now, right? Once you see all the stuff that's equal to each other. So that's called the side, angle, side theorem. I just shorthand theorem by just putting THM, all right? What do you think? You good with that? All right. Let's do this. Now, we're done with congruency, so what was the next thing we said we were going to talk about? Similar, okay? I'm not even going to write down what the definition of similar triangles are just yet. We will in a second. I just want to show you a situation. If my computer program can do this. I haven't tried this yet. I think it does. We'll see. Okay, now watch. Now, if I just copy and paste it, what's true about those two triangles? They don't just look alike. Yeah, they do look alike. It's true. But if I actually copied and pasted, what could you say about it? They're congruent to each other. Okay, we just finished talking about it. But watch this. What if I did this? I'm hitting the shift key. Does anybody know about computers? If I hit the shift key and do this, it keeps it in the same shape, it's different size. Give me a word. It starts with a P. It keeps it in. No. No. Give me another P word. No. No. It's proportion. It's in proportion. Okay? It's in proportion. My biggest pet peeve is as a photographer. If I can grab one of my biggest pet peeves is I can't grab this stupid thing. All right, there we go. One of my pet peeves as a photographer when somebody's doing like desktop publishing, like whether it's yearbook or a magazine or whatever it is, or just doing a newsletter or something like that. They'll take a picture. They want to fit it into a shape. They grab a corner and then they move it so it fits into a shape. And what happens to the person's head? They make it squish like this. So you ever see this? Like church bulletins are famous for this, okay, if you have pictures in there, or graphics. They try to fit it into a box. They take a picture that doesn't fit proportionally into the box. They'll just take one side of it, move it to make it to fit, and then they've squished everything, right? And then now somebody's face that looked regular like this, it's out of what? Proportion, right? It's not in proportion. You follow me? So what you would do is you would hit the shift key, grab a corner, drag it, and it'll keep it in proportion. Does that make sense? Okay, and that's what I did with this. So it is in proportion, all right? So that's very important. So now let's write, with that said, let's write the definition for similar triangles. Okay, so similar, I'll just put the symbol. Similar triangles, two things are true. The corresponding, I'll just put CORR for corresponding. I'll just shorthand it. So the corresponding angles are equal to each other, but the corresponding sides are not necessarily equal. They are in what? Proportion. Proportion. Okay? Now, there's a big difference between two sides being in proportion or three sides being in proportion than equal to each other or congruent to each other. Okay? Now, what's the first thing say? All the corresponding angles are equal. Again, let's go ABC again. And let's go DEF. Okay? And let's change colors. All right, what if I said that angle A equals angle D, and angle B equals angle E, and angle C equals angle F? Is that enough to say that they are congruent? It's not, because look at these two. It's pretty obvious to your eye that this triangle is what to this one? It's bigger, okay? It's the exact same shape though, isn't it? Okay, it's the exact same shape, but this one's definitely bigger than this one, or this one's smaller than this one, okay? But they are in proportion. So the angles can still be equal to each other, but the triangles are not congruent. If the triangles were congruent, I've said this several times today already. Everybody look up here. If the triangles are congruent, if I take one, sit it on top of the other one, it's exactly the same. Can I do that with these two triangles right here? No. If I took that smaller one, it would fit inside it, wouldn't it? It wouldn't, okay, it wouldn't fit exactly the same. So they're definitely not congruent. So they are what we call similar to each other, okay? They have the same shape, but they don't have the same what? Size, okay? Make sense? All right. But here's the tricky part. That's the easy part to similar triangles. The tricky part is right here, that the corresponding sides are in proportion. So let's try to make this as easy as I can. Again, I don't know if the math will all work with this, but I'm just going to do it anyway. So let's say that this was 20, okay? And this was, I don't know, 14, and this was 10, okay? We'll just say that, all right? Now, if I come over here and I told you that DF was 10, and I told you that they are similar to each other, okay? If I knew that they're similar to each other, if this is 20 and this is 10, take a wild guess what ED would be. Why? That's right. How did I get from one to the other? They're definitely not the same. This one's twice as big as this, isn't it? Or this one is half the size of this. So if this is 14, then this would be in proportion. So what's the proportion? It's the side is 7, but what's the proportion? This is twice as big as this, right? So that's got to be a 7. Make sense? What if this was 10? This is going to be a 5. Now, does every triangle, every two triangles that are in proportion, is every single one of them twice as big as the other one? No. One could be what? 3 times as big, 4 times as big, 5 times as big, or it could be some crazy number. It could be 4/5 as big, right? Or it could be 7/6 as big, right? So it's not always as simple as this. I just made it as easy as I possibly could with the twice as big thing, right? But the sides are still in proportion. So watch what happens when I do this. If I take this 20, oops, there goes That pen goes crazy. I push this button, and I don't know what it does when I push that button with my finger. And I don't know. I try not to push it. But anyway, if I had a 20 and I compared it to the 10, that gives me one side is twice as big as the other. So what is my proportion? If I reduce that, what does it reduce to? 2 over 1. So my proportion here is 2 to 1. Sometimes you'll see it like this. Sometimes you'll see it 2 to 1. Sometimes you'll see it 2 with a TO 1, or what's another way you can see it? 2 and then a what? When you compare two things. How about a colon? You ever see that? Okay, it's a ratio, exactly what it is. Okay, it's a ratio. So you could see it a bunch of ways, couldn't you? All right, but we're going to deal with the fraction probably most of the time. So that'd be 2 to 1. Now, the other sides have to be 2 to 1 as well. Okay, so are they? Is 14 to 7 2 to 1? Yeah, absolutely. Is 10 to 5 2 to 1? Yeah, absolutely. So if you compare the corresponding sides to each other, they don't have to be equal to each other, do they? But they have to have the same ratio. Okay, Nisi said it. It's got to have the same ratio. And do they have the same ratio? Yes, they do. So that means that these are what kind of triangles? Similar triangles. That's the trickiest part right there. The corresponding sides are in proportion. If they're in proportion, that must mean they have the same ratio. We good with that? Okay. How much time do we have? College Algebra 1025. Okay, we have time to do this. So here we go. With that said, let's do something. Remember how we had that side angle side, side side side, angle side angle thing for congruency? We kind of have the same thing for proportion as well. And the first one is called the angle-angle similarity. Are you writing it down? So that means all you have to do, I'll tell you what, just for the sake of time, I guess I could do this. Let me grab this one, that one, and that one. I'm just going to keep the same triangle every single time just for the sake of time, okay? So watch. If I had this, copy, paste. Again, notice what I do. I grab the corner. Oops. I grab the corner. If I did not hit the shift key, you see what it would do? Is that similar? No, because it doesn't have the same shape. Is that similar? No, okay? If I hit Control Z to get back where I was, hit the shift key, and then move it. Now, is it similar? Yes, because I didn't change the shape. I only changed the what? The sides. I wish I could grab that thing. There we go. Okay. So now, let's take a look. Let's use yellow since I went yellow. All right. What's really interesting about this is we'll call it ABC again, just for the lack of creativity on my part. Okay. So if I told you that angle A was equal to angle D, and if I told you that angle B was equal to angle E, that right there is enough to say that there are similar triangles. That's all I need to know. I only need to know those two things. Because think about it. Is C going to equal F? Why? Add up to be what? 180. Very good. Okay, that's perfect. They got to add up to be 180. So if I take these two away from 180, I should get the same thing as I get right here, right? Because they're same exact angles. So I should get the same thing for F. That's why they only put angle-angle similarity. Because I already know that C and F have got to be equal to each other, right? If the other two angles are equal to each other. Make sense? So if I give you two triangles and I say that these two correspond to each other and they're equal, these two correspond to each other and they're equal. If I tell you that, what could you say about these two triangles? They are what? Similar. Let's write them down. Let's go ABC. I tell you what, just to change things up a little bit, let's go BAC. What if I call this BAC? And I'm allowed to do that. What would I call the other triangle? If I go BAC, I'm going from 2 to 1 to none. I'm going to have to go EDF. Everybody see that? They got to match up, okay? The B and the E have to match up. The A and the D, the C and the F, they have to match up, all right? What's the symbol for similar? There's no equal sign. It's just one little squiggly. Okay, that means they're similar to each other. All right, so that means they are similar. Okay, let's do, how many more? 2 more? Yep. It's just one squiggly, one squiggle. And then paste it here. Again, I'm just going to make this one bigger. Could make it smaller. I'm just going to make it bigger. All right, here's another thing that they give you. Again, let's call it ABC, DEF. We'll just make it exactly the same. Okay, what if they tell you this? What if they tell you, now, I can't really draw this on the triangles themselves, but I can write it like this. What if I say that AB, if I took AB and I made a ratio with DE? You see that? If I compared this one to this one, made a fraction out of it, it should equal all the other ratios of the sides, okay, if they're similar to each other. So if I compare AB to DE, let's compare BC. What am I going to compare BC with? Compare BC with what over here? EF. And then, what else? Let's say C, we'll call it CA. What if I take CA? What's this one going to be over here? FD. Now, the reason I didn't put little tick marks on here, because I'm not saying that they're equal to each other. Sometimes I've done this. I put one little tick mark and I put one big tick mark, because this is a bigger triangle than this one. Does that mean they're equal to each other? No. Okay? Or I could go 2 little tick marks. What would I put here? 2 big tick marks. Does it mean they're equal? No. It means they're what? In proportion. I could put 3 little ones here. This is not like an official way to do it. This is just how I do it, just to show people what it looks like on the triangle. Doesn't mean they're equal, but it does mean that all sides are in proportion. So we call this, what do you think? Side, side, side. It's not congruency, it's what? Similarity. Okay? So it's called the side, side, side similarity. And I don't know if it's a theorem or a postulate. It might be a postulate. I can't remember off the top of my head. We'll just call it side, side, side similarity. Okay? That's a little weird, I know. But let's do one more. Let's do this. And then we'll finish with this. How much time do I have? Somebody look at the clock. 5 minutes? 6 minutes? Okay. Again, I'm going to make this one just a little bit bigger. We'll keep the same exact triangles. We'll name it the exact same things. Okay, and I will change color, though. How about that? So A, B, C, D, E, F. All right, now, they give you some other stuff. They tell you that this angle is equal to this angle, but they tell you that this side, the ratio of these two sides is the same thing as the ratio of these two sides. All right? Again, it doesn't mean they're equal. Don't get me wrong on this. AB does not equal DE. But the proportion, if I put the numbers in there and made a fraction out of it, it would come out to the same exact fraction as if I put a number in for AC and DF. Okay? Those fractions, remember how they had the 2 to 1 thing? That's what we're talking about here. So if the ratio of this one to this one is equal to the ratio of this one to this one, it means they're in proportion, then these two triangles are similar. So what do you think we would call this? Side what? Angle side. But we don't just call it side angle side. We call it side angle side what? Similarity. Doesn't mean they're congruent. It doesn't mean I can take one and pick one up and put it on top of the other one. They match up exactly the same. But it does mean that they are congruent. All right. Oh, I wish I had 5 more minutes on top of what I have. But let's do this. Come on. Save me 5 minutes if I could grab those things. And let's do this. And let's put some numbers and stuff in here. So what if I put a 3 and a 6? Okay, and then put a 5 right here. No. Let's see. I went 3 to 6. See, my triangles on my notes are way different than this triangle looks like, and I'm trying to get them figured out. So 6 goes with the x. Let's put an x right there, okay? And I told you that, I don't know, let's just say that's 30 and 60. Let's say that's 90, and that's 60, and that's 30. Do I know that these triangles are similar to each other? Why? Because all the angles, right? Angle similarity, right? I got two angles. I got these two, and I got these two. And I actually have the third one too, all right? So I know that they're similar. So how in the world could I solve for x? Well, I'm glad you asked. Here we go. We could do a couple comparisons. I could take 6 and compare it to the side on the other triangle that corresponds to the 6. What side over here corresponds to the 6? Yeah, I'm missing something. What am I missing? Oh, I got to put a 5. I know I was missing something. I'm like, what's going on? Okay, so what side compares with the 6 and x does? Let's set up a proportion. So now, if I take the 6, compare it to the x, I'm going to take the 3 and compare it to the what? The 5. Obviously, they're not equal to each other. I'm going to go 3 to 5, and now I can actually solve for x. Do you remember the math that we do? When you have a fraction set equal to another fraction, you probably remember this part. This. What do we do? What's that called? Cross multiply. That's right. Okay, there's a reason for it. We're just going to show you how to do it. If I multiply that, I get 3x. If I multiply that, 6 times 5, I get 30. Divide by 3, x is what? 10. And I just found that missing angle. Okay, so x is 10. So that's how you do these problems, okay? First of all, you figure out that they're similar, and then you set up a proportion, okay? You take a look. Let's do this in a different color. You take a look at this side. I thought I was in a different color. There we go, okay? I take this right here, and I see what side does it compare to. Well, this side compares to that, doesn't it? So I make my little ratio. Then I put an equal sign. And then I take a look at another side. Well, this compares to what side over here? Okay, this side 5. You see it? 6 goes with x, 3 goes with 5. I set up a little proportion. I do a little bit of math, cross multiply, solve for x, and I get what x is equal to. That's how you use this similarity stuff, all right? And that's some of the stuff that they're going to ask you to do here. All right, let's write down what the homework is. I already gave you the thing, but I'll write it down anyway. It would be pages 36 and 37. And this is section what? R3? Yep. And then we're doing 11 to 43. But you're only doing the odds. Yep. It's on your lesson plans. It's on your lesson plans. It said 11 to 43 odds. There it is. That's your homework. Get it done tonight. We'll go over it tomorrow. Okay? I'm sure you have questions on it, but give it a good try. Give it the best try that you possibly can, and we'll go over this tomorrow.